Hey folks, let's go. So I already did this once and then realised I forgot to turn the microphone on. So I'm actually going to talk through my answers rather than write them all out from scratch. Might be a little bit quicker than normal. Okay, so our first question, and I did like the Foundation Plus, it felt like very sort of standard things. Find an area of a semicircle in terms of pi. So all we're going to do is we're going to need to know the area of a circle is pi r squared and then halve it for a semicircle. Radius is 8 because that's halfway across the circle. 8 squared is 64, so half of that is 32, so that gives us 32 pi centimetres squared. Second question is Pythagoras, right-angled triangle, and we need to find the length of a side. It's a side we want rather than a hypotenuse, so we're going to do a subtraction. So 20 squared minus 6 squared is 364, and square root it to get 19.1. Third one, estimate for a mean. Again, this should be bread and butter by now. You need to put a column for midpoint, you need to put a column for fx, and then you need to, well, work stuff out. So the midpoints are in the middle of the points. The frequencies are summed up to get 100. The fx's multiplied across to get them, and then we add them up to get 2590, and then we divide the total of the fx by the total of the frequency. 2590 divided by 100 is 25.9. Standard form. So standard form is a number between 1 and 10, and then a power of 10. So the number at the front is going to have to be 5.5, because that uses all the digits and it's between 1 and 10. And then it's to the power of 10 because that's how far you'd have to move the decimal place to get from 5.5 to 55 billion. Or it's how many digits are after the first digit. 55 times 10 to the 9 would not be in standard form because the number at the front is not in terms of 1 to 10. Lastly, we've got a simultaneous equation. So I started up here. Put the thing they give you in terms of algebra. So we've got 4 adults and 1 child, so 4a plus c, 2 adults plus 7 children, etc. What I did from then was I multiplied the top one by 7. Now this might not be what you do, you might multiply the bottom one by 2. But I am really keen on getting the middle numbers to be the same, because it's then dead obvious whether I add or subtract. 7c and 7c, same sign, so we subtract. That gives us 26a is 195, a is 7.5, and then I sub that into 4a plus c is 33. To get that c had to be 3. I then actually checked that worked on the second equation, so 2 lots of 7.5 plus 7 lots of 3. Yep, that is 36. That works. It's always a good thing to do. Next one, we had a histogram, and for histogram you need to know this triangle here, frequency, class width and frequency density. So given the frequency, we need to work out the class width and then divide to get the frequency density. Class width is how wide a group is, so 0 to 10 has a width of 10, whereas 20 to 40 has a width of 20. And then the frequency densities can be decimals, that's fine. I then drew what the histogram would look like, which you don't need to do for this question, but it's worth bearing in mind. This is a bar chart with no gaps, where the y-axis is the frequency density, and the x-axis would be the ages, and you have all these bars. Next, another circle theorem question. There are 6 circle theorems that we should know. We should know that angle at the centre is double the angle at the circumference. We should know that opposite sides add up to 180, that's cyclic quadrilateral. We should know that angles in the same segment are the same, which is the bow tie. We should know that with alternate segment, bottom right is top left and bottom left is top right. We should know that tangents plus radiuses meet at a right angle, and we should know that semicircles have a right angle in them. And that's what this one is here. Semicircle, because it's got a diameter, has a right angle, so we take those two away from 180, we'll get x is 61. For this one, we have to find the gradient of the line. So again, if it's drawn for you, just draw a little triangle on it, count the squares. 4 over 1 is 4, but it's going downhill, so it's minus 4. Another line B is parallel to it, so parallel means the gradient is the same. So gradient is minus 4, and it goes to the point 20, so that's our x1, y1. So we can use this formula here. Y minus y1 is mx minus x1. So y take 0 is minus 4 brackets x take 2. and then expand it. Minus 4x plus 8 minus 4 times minus 2 is positive. And then we finish off with the tree diagram. So we basically get the first question right or we get it wrong. We get the second question right or we get it wrong. Probability we get questions right is 0.65. Probability we get them wrong is 0.35 because they've got to add up to 1. And then we want the probability we get exactly one answer correct. We would look along the lines. So 0.65 times 0.35 gives us 0.2275 for both cases. Add them up, 0.455 is your final probability that we get exactly one question right. Then onwards to higher plus, and this is, I think, the tricky question. So you start over here, sketching the graph. So if you're sketching a quadratic, which we are, you kind of want to look at a lot of values because you know it's going to curve somewhere. And it's said to go from minus 2 to 3, so I went to 4 just in case. So I went every one. Now I started with the positive values, so I did 0 squared take away 0 to get 0, 1 squared take away 1, 2 squared take away 2, 3 squared take away 3, etc. And then I thought, okay, well, there's probably some symmetry here. So if I know that that's 0 and that's 0, it probably then just repeats 2 and 6. But I did check. So this is minus 1 squared, take away minus 1, which is 1 plus 1, which is 2. Because minus 1, if you square anything, you get positive, minus 1, etc. And the same works on the other side. So I drew my blue line. Remember, because it's a curve, it should be sort of sketched smoothly. It shouldn't be dot to dot. And then this is the difficult bit. It says by drawing an appropriate linear graph, we want to solve this. Now, given what we've already drawn is x squared minus x, we want to rearrange this so it says x squared minus x. Now, to do that, I don't need to change the x squared. I do need to add 2x to get from minus 3x to minus x. So I add 2x to the other side. I also need to take away 1 to get rid of that entirely. So take away 1 on the other side as well. And I'll end up with x squared minus x is 2x minus 1 as a rearrangement. Now, this is best thought of as this curve equals this line, and I want to sketch this curve. So I drew a little table for y equals 2x minus 1, got these values out, and then I drew my line as the red line here. And then when does the curve equal the line is basically the question, so I wanted to see where they crossed over each other. And because it was in terms of x, I wanted to know the x values, where they crossed over each other. 2.8, 0.3 were my values. You might have slightly different ones depending on how accurately you drew and whether you used a ruler. But yeah, that's probably the toughest question. So we had to rearrange this to be the equation of the curve we've drawn equals the equation of a line. Okay, bit of indices. So you can't solve this until the bases of the powers are the same. This one's 16, this one's 4, so we need them both to be something, and I made them both 4, because 16 is 4 squared. Then I used indices rule, the brackets are multiplied, so we get 4 to the 2x is 4 to the 10 minus x, and then because they're both 4, I can ignore the 4's now. I can just say, well, the powers have to be the same. So 2x is 10 minus x, 3x is 10, x is 10 thirds. Then we've got a non-calculator indice question. There are 3 parts to this. The minus sign means it's a reciprocal, means we're going to do 1 over. The top number is a power, so that's 2. And the bottom number is a root, so that's cube root. So I want to do 1 over the cube root squared. Now it's generally easier, particularly on a non-calculator paper, to do the root before you do the power. So I cube rooted 27 to get 3, and then squared it to get 9, so it's 1 over 9. And then the last question was a quadratic inequality. Now we had this about a week ago. We want to find when is this graph below the x-axis, because that's what less than 0 means. So we need to find out when it's 0, and we can work out what the graph looks like. That means we need to solve it. So this could be solved in a couple of ways. You could use the formula, but factorizing is possible here. We know it's 2x and x, because that's the only way you get 2x squared. We know it's 3 and 1, because that's the only way you get 3. And we know they're minus, because that's the only way you're going to get minus 5x for what they add up to. And then you just need to think about whether it was minus 1 minus 3, or minus 3 minus 1. So you do a little check. This would give us minus 3x, This would give us minus 2x. Overall, that's minus 5x, so this is the right way round. And so that's our factorising. You could use MAM as well. X is 1.5 from this first one, because you flip the sign, divide by how many x, so 3 over 2. And x is 1 from the second one. Drawing the graph then, it's a positive graph, so it's going to have this shape. It goes through 1 and 1.5, because those are the values we found. And we want to know when is it below the x-axis. That's between 1 and 1.5. And this is how we'd write that. Okay, cool. A little bit quicker for me to do the answers ahead of time. Might do that again in the future. Cheers, folks. Have a good time. Bye.